Okay, so here's our third example. We're asked to solve for x. So this is slightly different than the other two examples we've done. And so in order to solve for x, there's a couple of different ways of solving logarithmic problems. And it all depends on where the variable is that you are solving for. Okay, so in this case, I have log base 2 of 16 is equal to 4. Now the left-hand side of this equation is something that I know how to solve. I just need to figure out 2 to what exponent will give me an answer of 16. And that'll eventually give me the answer for x. That's one way of solving this problem. Another way of solving this problem is to actually write this in exponential form and go from there. I think the first method's easier, where you can just evaluate the logarithm on the left-hand side, and then that will be the result for x. So, log base 2 of 16 I know is 4. And that's equal to x. So that one was pretty straightforward. Like I said, the other way of looking at this problem is to think, okay, 2 to the exponent x will equal 16. There's the base. There's the exponent that would need to be applied to it to get an answer of 16. And so I know that 2 to the exponent 4 is equal to 16, which means x has to equal 4. Okay, and that's what we had here. Okay, in part B, this one's slightly different. You'll notice that the piece of information that's missing is actually the base of the logarithm. So this one would be ideal to write in exponential form. So what this means is some base to an exponent of 2 gives you a result of 49. And I know you're thinking right now that base must be 7, and you're right. This is how you would show your work. X to the exponent 2 has to give you an answer of 49. And we know that if we square root both sides, we get x equals 7. Now you might be wondering why we didn't do plus or minus. Remember, every time you introduce a square root, you usually introduce a plus or minus. But the reason why I didn't introduce a negative is because the base of your logarithm cannot be a negative number. So that's why I didn't make this plus or minus when I found the square root. It's only a positive answer of 7. Okay, here's our next one. Again, we don't know what the base of our logarithm is. This one's actually a little bit uglier than part B. So let's write this in exponential form to start. So I have x to the exponent a quarter is equal to 8. Now, this one is not as easy. And what you'll notice is that it says the fourth root of x, and if I write this in radical form, this means the fourth root of x is equal to 8. Now, that's a little bit difficult to work with, so we can work around it by looking at this slightly differently. So I'm going to look at this in a different manner. I'm going to look at this as x to the exponent a quarter, and in order to make the exponent on x1, I need to apply a new exponent on the power. Okay, now think back to what you did in part B. In order to eliminate the square, you square rooted. And now to eliminate a quarter, I'm going to multiply this power, and I'm going to raise it actually to an exponent of 4. And if I do it to one side, I have to do it to the other side as well. And so what will end up happening is I get a power of a power, and I know that if I multiply a quarter times 4, I get an answer of 1. And so what this will result in is x to the exponent 1 is equal to 8 to the exponent 4. So now I have the x isolated, no other exponent other than a 1 on it. And if I use my calculator to evaluate 8 to the exponent 4, I get a result of 4,096. Okay, so what this means is the fourth root of 4,096, so the fourth root of 4,096 gives me an answer of 8. Now here's the last example for example 3. And so what I'm going to try to do is solve for x. Notice the location of x. So we've seen the variable be the exponent part as the answer. We've also seen what happens if the variable part is the base. Now the last part is if the variable part you're looking for is part of the answer part in your logarithm. So I'm going to try to isolate for log base 2 of x minus 1 first, and then we'll try to figure out what to do from there. So first thing I need to do is eliminate the 3 at the front. So I'm going to divide both sides by 3 since the operation right now is multiplication. And I get log base 2 of x minus 1 is equal to 6. Now, at this point, what this means is this base to that exponent, so 2 to the exponent 6, gives me an answer of x minus 1. So if I use that and rewrite it in exponential form, I can actually solve for x. So I have 2 to the exponent 6, which I can evaluate on my calculator. And I get 64 is equal to x minus 1. And if I wanted to solve for x, I would just need to add 1 to both sides to get 65 is equal to x. And you can check your answer to make sure what you've done is correct. And it should be right. Okay, so here's example 4. In this case, we're just asked to solve for x. And what you'll notice is we're starting with an exponential function in each one of these. And somehow we need to solve for the exponent part. Now, one way of doing this is using trial and error. So what I would need to do is try to rewrite 2 with the base of 1.5. And I'm sort of going to sit there and do trial and error to try to figure out what the exponent on 1.5 needs to be to get an answer of 2. Now, that's a very tedious process. And so using logarithms, you can actually evaluate this. So what I'm going to do is I'm going to use the power law of logarithms. And in order to use logarithms, they need to be introduced. So what I'm going to do is take the logarithm of both sides. So in the previous question, we looked at finding the square root of both sides. So as long as you apply the same